Hi everybody, good morning and welcome to this training session on designing a water quality investigation with Simon Browning from West Country Rivers Trust, and we've also been joined by Pete Lloyd, who's going to help us with the session today. You see that we're a bit different from the webinars we've been holding. We're holding this one in Zoom meeting because we're going to make it a bit more interactive. We're going to have some breakout sessions sort of partway through the morning. So the outline for the day, Simon's going to give us an introduction and overview to designing and planning a water quality investigation. We've then got a short recorded lightning talk from Pete Lloyd about improving chemical water quality monitoring, and hopefully you all saw the paper that was attached to the email that Pete had sent around, so we'll discuss that a bit in the discussion session. Then we're going to have the breakout rooms, like I said, where we're going to split into groups and have a go at actually designing a water quality programme, and we'll have a little break after that, but then we'll come back and give each of the groups a chance to sort of share what they designed and talk about the sort of decisions that they made and why they made those. And then we'll have a final discussion session where we'll pick up on some of the topics and questions that lots of you submitted for Simon and Peter to have a look at answering. So I think with that, I'll let Simon share his screen and kick off with his presentation.
Okay, so let's crack on then. Just to make sure. So yeah, this is the outline of what I'm going to be talking about essentially. A lot around monitoring, planning and design, and then because I think it's really a sort of you have to consider the data before you start monitoring. Then we'll go into a bit of how we might look at analysing, interpreting that. Then I say there'll be a bit of a break. Pete will talk to us as well about some of the ins and outs of spot sampling, and then we'll have a little breakout session where we'll get involved in doing our own monitoring strategy. So the first thing, really, before you get started in earnest, before you start browsing websites for monitoring kit, is really to get your objectives straight and really feeding from what the project objectives are. So it's very clear that very rarely is monitoring the end of the project in itself. Normally there's a project that the monitoring underlines, and so underlies. So it's important that obviously you're clear where the monitoring, what the role of the monitoring is in the overall project, so that you're helping the project objectives, and from that then you can start to set out your actual monitoring objectives in a smart way. And a little bit of thinking about this at the outset saves a whole lot of trouble later on, because you'll be directed to create the right kind of monitoring strategy. The end user of the data will know what they're getting, and will know what to do with it as well, and we'll all be clear about what's going on. And as I said just now, consider the entire data chain as well. So sort of present yourself forward in time and imagine, right, I've collected the data, what am I going to do with that? You won't know what the data will necessarily say, but in terms of how are you going to analyze that? How will that enable you to actually answer the questions that you're trying to answer? Yeah, and again, so you can work back from that, and that will help to direct you when you're faced with a plethora of different tools and techniques, choosing which ones you do, and as you go in to make those choices, know what you will still be missing. So if you like, so there'll inevitably be a compromise. I've never yet done a monitoring project where I've got all the budget and all the resources and all the kit to provide all the answers I wanted. So there'll be a case of prioritizing and compromising. But if you go into it with your eyes open and having considered these kind of parameters, then you'll know where those shortcomings are, and you can address those in other ways, or allow for them in your sort of experimental design. And then, yes, so try and think as well. This is something we come up against very often. You may be allocated a level of resource. You may have some cash for stuff and some staff availability. it's always interesting and really important to kind of factor in where the balance lies between the two. Are you cash rich but staff poor, or the other way around? And then possible partnership working, I would always say, you know, can you kind of expand or merge your objectives and your goals with someone else who's also got a little bit of money to not quite do enough monitoring for what they want to do. And the catchment partnerships are a perfect sort of platform to do that kind of partnership working. More and more we're talking to the Environment Agency as well now about how we can help them, how we can help each other on monitoring. So I'm going to give a couple of examples now. None of these are perfect, but I think it's always something we strive towards. Like I said, if we have those outlines in our minds, smart objectives and resources, you know, realistic about resources and compromise, then we can do the best we can. So one example I'm going to talk about is upstream thinking, which is a catchment management project we ran in partnership with South West Water, Devon Wildlife Trust, Cornwall Wildlife Trust, the Exmoor National Park Authority in the West Country. We're just entered our third 5-year phase, so 10 years down and 5 more to go. But really, the upstream thinking phase 2, which was 5 years ago till this March, was the first one where we had an actual budget for monitoring. In the first one, we did do monitoring, but we pulled in money from elsewhere. So again, even if your project funding doesn't have monitoring, you can sometimes use the project funding to offset against as much funding about, you know, pulling in some money for the monitoring. So the project objectives were quite clear, and there was a modest budget for stuff, but we did have the staff resource, the knowledgeable farm advisors working in catchments. So I was tasked really with setting up a monitoring scheme that would really make the most of them as a resource. So then, obviously with the same project objectives, we set out the monitoring objectives, which were, as it is there, to basically, we'd already done the catchment risk assessment, so we had a broad brush, we knew what, you know, data was telling us about pressures on these catchments. These are large catchments like the Tamar and the Exe and the Dart, so, you know, a lot going on. And when you spread 7 farm advisors across 5 catchments, it's quite a thin spread. So we wanted to direct them to the areas that were most in need of their attention. And we also, we're very clear that we wanted the farm advisors to do some of their own monitoring, a lot of their own monitoring, so that they could, with some direction, really get to grips with the water quality issues at the same time as they were talking to farmers and visiting catchments, looking at what's going on. So really building in that water quality knowledge to the people who are best placed to apply the solutions, if you like. So the kit had to be easy to use and robust. And then, you know, we were quite aware that monitoring these massive catchments for change over 5 years from some interventions made against the very noisy and shifting backdrop in terms of water quality and pressures on these catchments was always going to be a big ask. But we wanted to make sure that whatever we could produce was easily shareable with partners like South West Water and the Wildlife Trust, and also with the farmers and landowners. So again, we had to be quite, you know, that was in there at the beginning. We did have in the objectives to enable an assessment of change, but again, that's something we always thought was going to be a bit of a stretch for the kind of resources we had. When being tasked with setting up a monitoring project, there's lots of best practice and lots of, you know, the textbooks will tell you a certain number of things. So these are worth considering, this kind of the before-after control impact, the BACI kind of design, baseline data, paired catchments. But in all honesty, and again, it comes down to that kind of compromise, I've never yet had a project where someone said to me, Simon, you've got 5 years to monitor a baseline. Here's all the resources you need to do that. If they did, then I would have a heck of a job in sort of interpreting that baseline. Paired catchments and study sites, I've never yet found 2 identical catchments that are the same. So by the time you're looking at catchment scale, it's very, very difficult to do sort of paired catchments. And then the other thing is, when you get involved in a project, that even if they do factor in monitoring, they will never, in my experience, say, we'll just sit back here and wait for you to do the monitoring before we get going on anything. They always, you know, the people wanting to make the interventions always want to get going on those too. So, you know, they'll do that as well. And then, you know, are we really prepared to leave control sites alone while we work elsewhere? And then the other thing that certainly came out during upstream thinking was it's one thing to identify the areas in a catchment that are suffering the worst water quality issues, but it's quite another to make sure that you are able to physically make the interventions you need to in those catchments. You know, those catchments are probably the worst in water quality terms for a number of different reasons, and they're not likely just to be physical. You know, there's a combination of reasons. So I think this is going to talk a little bit about the various techniques that are available. So broadly speaking, you know, there's the spot testing approach where you might go and collect water samples from a load of different places within a catchment. And that might be on the spot testing, or you might go and take samples and send them off to a lab, or go back to base and process them there. Or there's the idea of leaving sensors in situ in one place to do continuous monitoring. Both those have cost implications, resource implications. As the kit we used for upstream thinking was designed and so that our farm advisors could use it, there are you can go down the road of citizen science type testing where literally anyone can use it, or some devices need specialist training, almost specialist staff members sometimes. And then yes, there's a trade-off there normally around with cost and complexity. You get increasing accuracy and specificity, but and the reverse is true. So how are you going to cope with that? So this is a bit more in depth on what we went for with upstream thinking. So the basic piece of kit we used was the fundamental one was the DR900, which is an optical instrument. So you take it around the field, you take a sample, you place the sample in the instrument, and then via various means, adding of reagents and or sending different wavelengths of light through, it can measure a whole host of different determinants. If you want, I think it will do 90. If you wanted to do all 90 in one test, you would need to be there probably for a week with a whole suitcase, another suitcase full of reagents and different gadgets and things. So, but there were some that we settled on that were sort of relevant and easy to do and robust for our project that are listed there. So turbidity and suspended solids, two measures of a very similar sort of thing. But if you're talking to a farmer, then you might want to be talking in milligrams per litre of sediment rather than formers in attenuation units. So that was why we kind of did both. Turbidity is the more robust measurement in a sense. The suspended solids is calculated from that with a sort of global calibration. So it's a kind of a rough approximation, but at least like you can talk to farmers in units they'd understand. Colour is, again, it's a very easy one to measure and of high relevance to surface water. And phosphate, of course, is a key one for us. And the way this gadget measures it, we weren't filtering because that added an element of cost and time on site and fiddle factor. And remember, we're trying to keep this simple and quick for people to use. So we just went for unfiltered phosphate, which is a reagent. And then the little stick on the left there is a pocket tester from HACC as well, which did temperature, total dissolved solids, and conductivity. And again, that's the same sort of thing as the suspended solids. Conductivity again is the basic measurement. It's interpreted as total dissolved solids, but again, if you're talking to farmers and non-experts, I would much rather explain dissolved solids in milligrams per litre or parts per million than conductivity in microsiemens per centimetre. So it's just a case of interpreting that data. The pH, we went for the gadgets with pH, but those pH sensors are they're sort of disposable. We got decent data out of them for 6 months or so, but then they became a real pain to calibrate. So then we moved on to just the TDS probes, dissolved solids probes in the future. We also then had, in terms of resources, we had enough kit for enough cash for 7 of those kits. It's also worth saying the suitcase there, which they don't come like that. We bought those suitcases and picked all the foam out and they've got a little receptacle in there for waste and for all the cleaning cloths and things. That's really important because it means that those two bits of kit, which are relatively simple, but a bit of a handful, become easy to use then in the field, and that's really important. Enough for 7 of those, but only enough cash for 1 each of these, which our monitoring team use. This is a dissolved oxygen probe and a fluorimeter, which is the tryptophan fluorescence is really good at picking up organic pollution like slurry, silage liquor, sewage, that kind of thing. So again, very relevant for the sort of thing we were looking for. We did also look at some in situ kit where we could afford it, and this was primarily deployed alongside our passive samplers. So a big focus of the project was pesticides, acid herbicides, and metaldehyde, and the passive samplers we used for that. We deployed the in situ continuous loggers where we deployed the passive samplers. So the passive samplers, in case you don't know, you deploy for a couple of weeks. They basically absorb anything that goes past in the river selectively for those pesticides. And at the end of the 2 weeks, they're analysed in a lab and you get the result back, a sort of a time-weighted concentration of what went by in that 2 weeks. So what we use the temperature and conductivity loggers for, you can see on the graph on the left, is to record data of what was happening in that 2 weeks. And this was quite a nice example. You can see on the left-hand side, the first 2 week deployment, and the purple, green and blue lines are the levels of, what are they, 2,4-D, fluoxapyr and MCPA. So quite high, and in the second period they're much lower. The continuous data tells us that in the first period we had a couple of small sort of rainfall events and 1 big spike in conductivity. The second period shows we had 2 big rainfall events, and you can see the dilution in conductivity. So what that tells us with some confidence, is not perfect, but it's highly likely that the pesticides that gave rise to that high concentration on the passive samplers came through during that runoff events that also generated the conductivity spike. So we'll be looking at this in a bit more detail later on the exercise, but there are a whole range of different things. What I've done is I've kind of given each one a score for various ease of use and accuracy and things. But there's hundreds of different things you can use to monitor the environment that are within our reach. These are all field-based bits of kit and fairly straightforward to use. So you'll be looking at these in a bit, and then you can. But this is just an explanation of how those kind of trump cards work. And as you say, it's well worth understanding when you plump for a bit of kit at a certain cost. Where it sits on this kind of on the spectrum between accuracy and selectivity. What parameters, how appropriate are the parameters for what you're actually trying to measure, and how easy is it to use? Are you going to need to employ a PhD or an engineer to run the kit, or is it in the window where you can have volunteers and citizen scientists and non-technical people run the kit? So you've done your monitoring, or you haven't yet, but you're considering the data. It's an important part of the whole picture, and so some points here to consider. How will that data get back to you? How will you move that data around? How will you analyze that data, and then what will the results look like, and who will you be showing them to, and what is the kind of desired impact you'll have? What are you trying to get people to do on the back of those results? And I'm going to run through some examples that takes us through that chain. We use a system called Cartographer for all our data, and it takes us through the whole data chain, which is quite nice. So I'm sure there are other ways of doing it. This is quite a neat one, and it does illustrate some of the issues around data. So we use this system for both our citizen science scheme, West Country CSI, and for what we call our UST monitoring, but it's actually the monitoring that's done by our in-house kind of either land team or monitoring team. So it starts with a paper form. It's important that on there we have a number of things around, so not just the parameters we're measuring with the sensors, but other issues around where we are, when we are, obviously who's monitoring, and then conditions around flow. Flow is really important. Pete will talk more about that, but what you find in the water is very dependent on what the preceding conditions are, rainfall and flow. And so if you're getting a high turbidity in dry conditions, that means one thing. With high turbidity after a storm will mean something else. But yeah, so initially in the field, it's a paper form, and then that's translated into a digital form on the website, which just replicates that, but allows us to do some things like picking points off a map and adding photographs in. And as I said before, I covered it up with the picture some error trapping stuff. So if someone enters a pH of 75, you can flag it and say, are you sure about that? And that can be quite sophisticated if you have rules in mind that you want to adhere to. The other thing about Cartographer is it enables us to have a very quick, so that data is taken in and then can be displayed on an online interactive map. So the farm advisors, what we wanted to avoid, and this is brilliant, was them going out, collecting data on paper forms, stashing the paper forms down the back of the seat in the car, and us never seeing them. So the way it worked is as soon as they enter that data online, that data is available to them. So the trade-off is if they enter that data, they get this feedback straight away. They can see how their surveys match up with previous work, and we get that data as well. We get a notification saying the survey's been done, we can check it, and we can then access that data. And what Cartographer does, it not only shows, these are the main sort of upstream thinking catchments, with also, this is some work we did with Denmark Wildlife Trust on freshwater pearl mussels monitoring. So they can see all that data, and if they click on a point, and there's probably that point there clicked, you also get a timeline for the data you've collected. So again, some quite, without anyone having to crunch any numbers in Excel, you can get quite a good overview of what the data is telling you. And this is the citizen science data set actually looking at, I think this is phosphate levels. So again, the same thing applies to our citizen scientists. We don't need to worry about where that data is. We know where it is. It's securely stored, and we can access it, and they can access it. And as I said, also allows you to add photos in, and those photos appear tagged to each survey location in timestamps, so you can scroll through, pictures of that site over time. In terms of getting the data back out again, you can filter it inside Cartographer. This is Lydia now works for us. She started out doing CSI. She works for us now running the CSI scheme. And so, you can filter on any name, date, whatever you like, select a subset of data. And then it's a simple click of the download to download it all as an Excel file. And then you're away into Excel. So what we did this is the freshwater pearl mussels analysis. And again, it comes down to what you're going to do with the data. We took all that data, split it up by survey, did some basic stats on it, and then ran through this process where for each site, we would basically highlight the number of times it appeared above the median for that survey. And this is a way of normalizing results across different conditions. I won't go into that now, but the upshot of it was, it allowed us to produce this kind of ranked scorecard where we fairly sort of crudely gave each site in the monitoring matrix a ranking between, what are we, 15 sites, so between 1 and 15, according to the total dissolved solids, the sediment, the phosphate, the colour, and in this case, the tryptophan. And that gave us an overall ranking, which so then we can then sort on this ranking. And this picks out some interesting things. So this was done over about 15 surveys over around about a year, I think. So quite a good sort of baseline of what's going on. The point of this, it was about targeting interventions really. And what's quite interesting is you can see that, say, site number 5, Iddesleigh Stream, is coming out top overall. It's pretty, ranking quite highly, as in bad, across the whole scores. But into the data, you get other interesting things. So the river oakment that comes in off the moors, it's a very different part of the system. Although it scored very well, it was much higher for phosphate. Not high enough to take it high in the rankings. I think we know why that was, but there was no need to investigate that for this project. But I think there's a sewage treatment works up there near Oakhampton that was giving consistently high phosphates. But there's some other interesting patterns in some of this data where sites will score particularly badly for one parameter. So the idea that, some are consistently good, some are consistently bad, I think where you get a mix of the two, it really opens the door to asking further questions. And that's where we might go on to a second phase of monitoring, where we might say, right, now we have some information about what might be going on here, can we devise a monitoring program that will tell us more about that particular issue? So this kind of spot monitoring is very much as a kind of a first pass, where will we find the biggest issues. As we kept doing this kind of thing, we incorporated it into different reports and played around with the presentation. So in this case, we've taken that same scorecard, but now presented on a map. So each monitoring point, we generate the contributing catchment to each monitoring point, and then just assume, just basically assign that level to that whole catchment. So there's obviously some massive approximations made there, but in terms of, again, highlighting areas for further attention in a catchment, it's been really useful, and that's pretty much what we've stuck with now at the moment, actually, is that kind of approach. We find that really works well for engaging all sorts of people. In terms of our monitoring, we probably wouldn't want to go much smaller scale than this, because this identifies, some sub-catchments. We're not in the business of identifying particular farmers, really. If I could send John or Ross into the Derryll water catchment, that's enough. He can go and visit the farmers in there and say, you've come to our attention because, without, the actual knocking on farmers' doors and waving the big stick is not our role. Then you can also present the data behind that. So this is the phosphate measurements, again with our HAC DR 900. I won't get into the specifics of that instrument, but they're not as sensitive as lab instruments or lab measurements, but you can see by the data we're getting there, they're about right for the sorts of levels we're finding. We are picking up plenty of variation in our catchments. At those levels, we don't need to be looking below sort of 0.1 milligrams per litre in any real detail. So then, taking that approach, that kind of presentation of data, I've just ferreted out some examples here from the Chesapeake Bay region in the US. They've got a really good website, and I can put the link up or send the link through another time, where you can go and look at a number of different organisations within the Chesapeake sort of monitoring cooperative area, where they've each presented these kinds of data in different ways. So what I like about these is it's a really good way on 2 sheets of A4 to present not just the current status of the river catchment in whatever level of detail you've got, but also to present some of that kind of background information and some of the information around the processes of how river systems work and what the pressures are. And that's really accessible way of doing that. Some really nice examples there, which again we are always looking towards how we can kind of improve the accessibility of our data. This is another one. So again, it's interesting that people are assigning rivers, sort of grades as if they were GCC results. I think that's interesting, especially with the talk around Water Framework Directive at the moment and how we present this water quality data. Actually, sometimes the simplification of data, well, obviously it's a massive massive issue, but how you best get the end result is what matters, I think, to a large extent. And if you're using a system that puts people off being able to interpret it, then maybe that's not the right way of assessing water quality for the audience that you're looking at. And so some of these scorecard measures, I think, have a real merit. And yeah, just another example again of presenting. This is all basically spot sample data, probably field testing, a lot of it, quite basic parameters, but in a really accessible way that I think gets the point across really well. I think that is the last slide. So for now, so that's okay. I'm about on time. I'll stop sharing. And then we should be back to everybody. Hello.
Okay, thanks very much, Simon. That's brilliant. And I think just a reminder to everyone, if you have any questions on any of that, please do post them in the chat and we can pick up some of those at the discussion later. So what we're going to do now is hear a little bit from Pete Lloyd, just to sort of further round off the sort of intro session. Pete has recorded a short presentation for us, which really sort of drills down into some other issues that you need to be thinking about when you're planning your monitoring work around the limitations of spot sampling versus continuous monitoring. So Pete has, he worked for a long time for the Environment Agency and their monitoring team, so has really good insight into monitoring for consented discharges, particularly sort of around sewage treatment works. So that's what his example is going to focus on. So Lucy, if you could play that, please, that'd be great.
The quality of many rivers is affected by discharges from sewage treatment works. So it's essential to have reliable data on the quality of these discharges and the impact that they have on the receiving watercourse. Now, the present policy for the regulation of sewage effluent discharges is that the water companies take a small number of random spot samples of effluent every month, mainly confined to the working day. The results from these samples form a database that's used for many purposes, and it's assumed that the data provides a good indication of the overall performance of the works. But is this really the case? This slide shows the ammonia concentration results for the 2 samples that were taken in 1 month from a sewage treatment works. The results are very low, suggesting that the works is performing well and not having a harmful effect on the river. But does this data give a true reflection of effluent quality? A continuous water quality monitor was deployed at this works for the same month, and these are the results. A completely different picture. The blue trace is the ammonia concentration of the effluent for the whole month, and the 2 spot samples are also shown. In reality, the works is in urgent need of attention, and it is likely that there is an adverse impact on the river. I should emphasise that this is not just one isolated example. This is another example from a different sewage works, showing the continuously monitored ammonia concentration for 7 days and the 3 spot samples that were taken during that time. Now, there are a number of factors that cause this discrepancy, and the main reason is that due to variations in incoming flow to a treatment works, it is often the case that worse quality effluent is discharged during the late afternoon and overnight. I'm not suggesting that all sewage works are like this. Most are well managed and produce good quality effluent, but there are over 2,000 sewage treatment works in the country, and continuous monitoring data is only available for a very small fraction of these works. So the fact is that we simply don't know what the quality of effluent is for the vast majority of works. Maybe only a small percentage discharge poor quality effluent, but that still might account for many of the water quality problems that we have. Now, because the existing monitoring system doesn't provide reliable information regarding the quality of a sewage effluent discharge, it's essential to consider this when undertaking any monitoring of a river as a point downstream of an effluent discharge. In this slide, the blue trace shows the ammonia concentration of effluent for a 3-day period from a sewage works, together with the red trace for ammonia concentration in the river several miles downstream of the discharge. And this slide shows just how easy it is to misinterpret spot sample data. The yellow band shows the working day when samples are taken. So it can be seen that samples will not be taken at the sewage treatment works at the time when ammonia concentrations are at their highest. But these high concentrations from the sewage works, which are not sampled, will affect downstream river quality during the daytime when samples will be taken. When comparisons are made between the monitoring data for the sewage effluent and the river quality, it can easily be concluded that the sewage works is not responsible for poor quality downstream, and that there is a diffuse source of pollution between the sewage works and the river sampling point. There are also very serious implications on users of historic data, because the agency doesn't provide any warning to users of the database regarding the deficiencies of the data. This means that the results from many projects and modelling studies could be compromised. And that's about it. Thank you very much.
So thanks for that, Pete. And we'll have a chance to have a bit more discussion around that after the interactive session. So if I could just ask Simon to join us again. We're now going to move on to our sort of breakout session, but before we do, Simon's just going to give us a quick introduction to what we'll be doing.
So now, hopefully you can see on the PowerPoint slide titled Design a Water Quality Monitoring Strategy. So what we've got for your entertainment is I've picked on a real world problem that is bubbling up here where I live. Actually, I live in Bude, and essentially we've got, then you'll be given a PowerPoint slide with a big map and these monitoring sort of cards to shuffle around as you wish, the ones you choose. So the synopsis is probably on the slide that you'll get. The only catch is there'll be 3 different breakout groups, and we've got 3 very different budgets to work to. Now, because there's a whole host of variables that will govern exactly how much these kind of monitoring things cost you, we don't need to worry too much about that. You can consider this budget, imagine you're bidding into a funding source and they've given you a guideline around what the capital funding will be. So I'm not going to expect, properly costed out proposals and stuff with staff time and mileage and all that kind of thing. But it does need just to consider in your sort of deliberations the balance between technical capital stuff, kit, and the staff resource needed to run it. So just sort of as long as that's considered. Yeah, and it's basically it'll be 18 months. And again, this is quite a sort of a realistic prospect in the sense that, I mean, some of the budgets aren't realistic, but in terms of, in terms of the timescales given. So again, 18 months, at least it will get us 2 sort of wet seasons, 2 winters should be, hopefully, and some time between to direct stuff. So yeah, I'll be floating between the breakout groups, and there'll be a facilitator in there with you as well. So any questions we can get into once we're up and running, I think.
Okay, I think we'll kick off again. What we're going to do now is ask each of the 3 groups to give a quick bit of feedback on what they decided to do. Simon, I'm not sure which of the 3 groups we had, or Lucy, do you know who the facilitators are for each group? James was going to give the report for ours, but we were the 75k group.
Do we want to start at the low budget end and move up? Yep. Okay. So that was my group. So I think Mark, you were gonna give the update. So maybe Mark, if you're back, if you can turn your camera on, and I'll share my screen.
Okay. Great. Okay. So we were at the lower end with a budget of £2,500. So we very quickly settled on a citizen science driven project, but we also recognised it would need to be very focused. Looking at the catchment, we decided to spend money on 2 cameras. Here we go, that's my shopping list. It's 2 cameras, a rain gauge, 20 citizen science kits. We then decided, after spreading that money across, we could afford to link the 2 cameras via telemetry, which was we felt was important. I'll go into that in a minute. And we left £250 of the budget for training citizen scientists at the outset, but also for phosphate testing later in the project. The project was split into two parts. The first part being cameras on the two main tributaries before the upstream of the confluence of the two tributaries feeding the canal, and a rain gauge in the western area of the western part of the focus area, catching the prevailing weather. We then decided that we would go for a farmer and volunteer citizen science focus, so some training, some citizen science kits, and also riverfly kits, but I'll come on to that later. After the training, we would conduct a walkover, identify the fields that we felt were contributing to the problem, and that was also to include a wet weather survey. The approach we would take is monitoring upstream of confluences and downstream of confluences to narrow down our focus, investigation focus. And having narrowed that down, we would then be able to do things like phosphate testing and speak to farmers in the areas concerned. We also felt that riverfly would be a worthwhile investment to engage the volunteers with, and would underwrite the whole programme. Would anyone else like to add anything? Have I missed anything?
I think that captures everything we discussed. We just put a few monitoring points to sort of illustrate that we'd be asking people to monitor upstream and downstream of the confluences. We didn't put them everywhere because, as Mark said, we'd be using that process of sort of narrowing down with looking at things like SciMap and land cover first, and then narrowing it down further through the kind of walkovers. And the point of the cameras, I guess, was to give us an idea of whether to focus in the south of the catchment or maybe in the north of the catchment. So I don't know if anybody else has got anything else to add. No. Simon, have you got any comments?
Yeah, I think that's really good. That's really impressive. For that, it's a tiny budget, and so obviously you're nudged down the route. But that's kind of what I would do is kind of shove in the kind of appropriate level of technology that you need to kind of get you further along. And I think engaging the farmers to do the citizen science is fantastic. There's a real you've really got sort of skin in the game with soil loss and stuff, so getting them on board and tooled up would be good. I like the idea of the cameras. Obviously I live right there, and at that confluence it's very, whenever there's any rain, it's very clear there's normally a difference in the two rivers joining, like you see in the Amazon when the Black River joins or whatever. It's not always in the same direction though, so it's not necessarily clear cut. I think the feeling is the lower catchment, the Neet is slightly more prone to sediment runoff, but it's not always the same, because we do get quite differential rainfall rates sometimes with these storms coming across. But no, I think that's really good. Very good value for money. Okay,
thanks, Mark. Should we move on to the group that were with Annika? I don't know who was going to give the feedback.
Catherine, can I pick on you?
Yeah, pick on me. So we were quite weighed down with the responsibility of this 25k budget, and we decided that we weren't really comfortable deploying anything until we had firstly spoken to a lot of the people who work in the area. So speaking to Rivers Trust, if they'd done any walkovers and had any knowledge about particular problem areas, spoken to CSF, again for the same reason, and then did a bit of a desk study of the existing data to try and pinpoint where the problems were. So that was going to be the first phase of our project. So looking at the whole catchment and trying to narrow it down.
And running the SciMap model.
And running the SciMap model, yeah, just to, because we're starting out from having no idea how this catchment works, and there will be a lot of pre-existing data and knowledge about where the problem areas are. So yeah, we're a bit of a stick in the mud and saying, well, we're not going to put anything anywhere until we know more. So once we'd done that first phase of the project, we decided that we'd quite like somebody dedicated as a part-time role to coordinate a citizen science approach. So we're going to have that element of the project, but we're also going to deploy, can you scroll down, Annika? What did we agree to go for in the end? Yeah, we had turbidity loggers on, yeah, sort of where Annika's pointing on the map, so to look at where the sediment was coming from, but the location of those turbidity loggers is going to be informed by our desk study in the first couple of months. We're also going to try and do a push for riverfly as well, so to tie that in with the citizen science side of things, to get a nice indication of sediment loadings over time. So there's probably some existing riverfly locations in this catchment, but to try and use the time that we had with somebody dedicating the time on the project to do a bit of a push and get more riverfly locations up and running. We were also going to get some multi-parameter colorimeters to deploy to the farm advisors, so we could really start to target down within the catchments, the sub-catchments, once we'd identified them. Was there anything else that I've missed? Anybody else who's in the group?
I suppose we said we were going to do a phased approach, where the first 6 months we were going to do a broad brush assessment, and then the remaining year we were going to do more detailed investigations.
Yeah. Yeah, basically we're not going to just jump in and buy a whole lot of equipment. We want to take our time and really think about it properly and get as much information as we can.
Have you got any reflections on that one then, Simon?
Very, very interesting. Yeah, so, well, what's quite interesting is that, and I'm quite pleased that, you know, even though you've got a bundle of cash, you still kind of look at the citizen science approach, because I think that does give you a lot of, you know, so social capital almost in the catchment that makes a lot of stuff easier. It's also interesting that it's essentially done the same sort of job as the first group, but with using the turbidity loggers instead of the cameras to give you that kind of differentiation between the two main, you know, north and south, the Strat and the Neet catchments. I would say that almost the thing with turbidity data is, without flow data or without somehow calibrating it against suspended sediments, even though you've got a number and quite a, you know, a precise number over a picture on a screen, you know, in some ways you're not that much further on.
Than the camera.
Yeah, you can be, you know, with a little bit of, so maybe with deployment of water samplers or some sampling and you know, some event-based sampling. And again, that's where the volunteers might come in handy, because, you know, you might persuade somebody to sit there, you know, for 12 hours in a rainfall event and fill bottles of water that you can then test later on. But no, yeah, so that's what I'd say, that, you know, you don't always necessarily get the best data just by spending a bit more money. You need to kind of you know, some of these expensive instruments only do half the job for you.
I think that's quite interesting, because I think a lot of us are just so used to trying to do everything on a shoestring that when you're presented with a bigger budget, it's a bit overwhelming and you don't know what to do with it. So I think it's really helpful. It
does help to focus the mind when you've got a tiny budget. That's for sure.
Yeah.
And also you can manage expectations, you know. So the important thing, the interesting thing is with these bigger budgets, the expectation of a client will go, you know, up. So we're really interested to see what the last group come up with their £75,000.
Go on, Michelle, who was going to feedback?
So I will share the screen, and James, I think, is going to give the roundup. So yes, I've added some notes, James, which might help us remember what we talked about.
Cool. So just from the start, one thing we definitely missed off, but should definitely inform any investigation, is that prior desk study. So what water quality WIMS data is already available that can be interpreted perhaps to inform the study. Models, SciMap was mentioned. There are also other models that could help to inform the deployment of the study. So that's definitely something that should absolutely go ahead of any such investigation. And broadly speaking, our approaches are roughly similar to the two that have already been presented. So first, again, we're having a phased approach, and the first phase is very similar to Mark's, the approach that Mark presented. So the idea was that we'd have an initial 3-month sort of quite broad investigation, utilising 3 turbidity meters that we would also use in combination with turbidity tubes, which would enable a calibration of those tubes for the catchment. And in doing so, we would kick off a citizen science study for the rest of the investigation. Furthermore, we'd also include pocket testers to take a measurement of conductivity. The idea being that could help inform the flows that were present at the time of taking a sample. The assumption being that you would observe a drop in conductivity when flows are up. You could also combine that with, Michelle mentioned the Crowdwater app, which enables relative level measurement. I don't know if you can add anything more to that. That's new to me, Michelle.
Yeah, it's been used for sort of measuring river levels in ephemeral streams, but it basically is like a virtual river gauge that you can put on a photo, you know, sort of fixed point photography, go back to the same site and put the sort of gauge on, and you can see the relative river level compared to last time you were there. I'm not describing it very well. I think it's easier if you actually use it, but yeah, Crowdwater, I'll put the link in the chat later.
And most importantly, these investigations would be targeting wet weather events, but not entirely, but the thinking being obviously that the sediment loss is driven by wet weather events. So that 3 months would go to inform deployments of in situ equipment and other sites that would come into play in phase 2. We'd also deploy 2 rainfall gauges across both subcatchments, which Peter mentioned that there's websites available that might help on top of that. But if there is no data available, then we would definitely deploy these rain gauges. So as I mentioned, the second phase is then ultimately designed to gather some really high quality, high resolution data of the 2 subcatchments, the main idea being to derive loadings from each subcatchment, and to do that we'd install 2 V-notch weirs, one at the pour points of each subcatchment, and then sort of fanning out from there, we would deploy our multi-parameter sondes, auto-sampling kit, etc. And then another thought was, whilst this is very sediment focused, whilst we're collecting in situ multi-parameter data, that another thought came to mind about the bathing water and the condition of that bathing water. So perhaps we can start looking to other determinants than just sediment, turbidity, conductivity. So perhaps fecal coliforms could be analysed for in the lab from the auto samplers, etc., to start informing that, and that could have spin-off projects to sort of ensure the monitoring keeps on happening, basically. I think that was pretty much it, unless I've dropped anything off.
Well, I think you've pretty much covered everything there, actually. We did have a bit of debate about whether we'd be better off buying the expensive kit or hiring continuous monitoring kit for £1,000 a month. I think those of us in charities felt we may as well buy the kit with the budget, and it can be reused on other projects. But you know, you can do a bit of a mix and match potentially. If you buy the kit, you've obviously got to then maintain it, calibrate it. You know, it will depreciate. So Simon, what do you think of that? I don't think we spent all the money. We were struggling to spend it, to be honest, but I think you'd need longer to really do it justice.
Yeah, that's the trouble, you know, with these kind of, the choices you have to make increase exponentially, you know, with increasing budget. That's the thing. But no, again, really pleased to see the citizen science approach in there. I think that's well worth factoring in whenever. And actually a really nice sort of blend of bits of kit. You've not fallen into the trap of kind of kitting the whole, you know, turbidity sensors everywhere and putting all your eggs in the basket of online, you know, continuous monitoring, which I think is quite is a solid approach. You've got a mix of sort of techniques there. The only other thing I suppose is that does then you're left with an awful lot of various data sources that you need to try and pull together. But you know, with the kind of phased approach, I don't think that's necessarily that's not insurmountable. You know, presumably you'd approach each phase with a clear plan on what it was designed to test and what you were going to, the data would get out of that and how that would inform the next phase. So that makes sense. It's interesting as well that, you know, the idea, the sort of question of what existing data sources are there. The Environment Agency have monitored this catchment quite closely for, you know, the bathing water teetered on the edge for a little while a few years ago, and then there have been improvements made to the water treatment and sewage disposal kind of infrastructure, and it seems, but so now actually the catchment, whether it gets good or excellent water quality or poor, is very dependent on wet weather events during the summer, during that bathing period. So the agency have done quite a lot of work here. There are a couple of rain gauges, one in the north and one in the south. And they did for a long time actually have a continuous water quality sonde in the river down by the beach that was displaying real-time data on water quality on the lifeguard hut. That seems to have kind of fallen into disrepair now, but that was interesting. It was only really me who looked at it, I think, but the reason it was there was so they could discount samples. You know, in the approach was taken that if the screen is up there, then that's deemed that that's informing people, and if a sample fails but the screen was on, then, you know, they could discount that one. So yeah, quite a lot of previous work has gone on here, and, you know, by engaging people like the Environment Agency on those issues that matter to them and South West Water, yeah, you could bring in more money and resources to this project, I think.
Okie dokie. Well, we've got a fairly short time left, and we did want to allow time for a bit of Q&A, and there were some questions that were submitted before the workshop, so I would like to maybe invite Pete and Simon to sort of share their wisdom by posing a couple of the questions, if that's all right. I know, Pete, you had written some replies to these, but I think it'd be good if you and Simon can just give us a sort of bit of a verbal response. So one of the first questions that we were asked was, let me just dig it up. Okay, what would be stated as the top priority water quality measures to ensure we always capture during monitoring? Simon, would you like to go first at having a stab at that one? So what would be stated as the top priority water quality measures to ensure that we always capture during monitoring? What should we always be measuring?
Yeah. The first thing that sprung to mind there is actually the thing you want to make sure you're measuring all the time is not the water quality, but it's almost the metadata. So I think Pete alluded to it in his paper as well. And it's certainly something we factor in our survey design forms, is you need to know obviously where and when the sample's been taken, but the other stuff around what the weather and flow conditions are, who's taking that sample, what they're taking it with, so that data retains that kind of hallmark of traceability wherever it goes. I think that's really important. The other, and then a really useful, I mean, obviously it depends on what your objectives are and what you're after, but in terms of a tool that I would always have in my kit is conductivity. The way the sensors work, they are relatively low cost, but still fairly precise and accurate. And although it's a general indicator, you know, in terms of cost for value for money, really you can't do much better than that if you're on a really limited budget. Even this little thing here that we use for our citizen science, you know, that costs about £5, I think, and it's, you know, it's really, they are good enough to tell you a difference between, you know, sources and different catchments, and fairly reliable. So I'd give a shout out to conductivity. Then the other thing, I suppose, with our citizen science, we have a nod to the turbidity tube, because really once you've got the conductivity and turbidity, you've got a kind of, the way I explain it to our volunteers is you've got what's dissolved that you can't see and what's suspended that you can. Even if you can see the bottom of the tube, you can still see the colour of the water really well in these. So you've got then an easy assessment of colour, or, you know, what's dissolved and what's suspended.
Okay, thanks, Simon. That's good sort of assessment. And Pete, would you like to respond to that? So just a reminder of the question is, what would be the top priority water quality measures to capture, you know, in every sort of monitoring event?
Okay, well, first of all, I pretty much agree with everything Simon said, so I won't repeat all that. Just to emphasise, though, you're not going to get very much information from a few isolated individual samples. So it's best to try and forget about just going down to the river and taking a sample and thinking that's it, because it's not going to tell you anything really. The things that people forget, again, Simon mentioned it, flow. You absolutely have to know what state the river was in. Not necessarily an accurate flow, but you have to have some idea of those conditions. And you really want to know the other conditions, the weather, not just at the time of sampling, but the weather for perhaps, you know, a few days before as well. And the main parameters really are always going to be dissolved oxygen, temperature, ammonia, conductivity, and turbidity. But again, it will come back to what your objectives are.
Okay, thanks, Pete. And I mean, just a bit of a question to everyone on the call, really, because it's something we've started to look at. We're planning a bacterial water quality monitoring day on one of the rivers local to us, and we're going to need to get hold of that sort of weather data and find out what the rainfall was for the sort of maybe week, 10 days before. What would you say is the best way to access that data? Could we put in a request to the Environment Agency, or because I know Met Office data isn't always freely available. It's not something I've had to try and source before, that sort of near real-time rainfall. Anyone got any recommendations for how we can access that, or would it be good enough just to look at some online metadata and have a sort of estimate?
The Environment Agency will be able to help on this, definitely. And one of the key things is rainfall radar data.
Okay.
Well, so there's obviously the EA rain gauge network is pretty good. And there's an easy sort of interface to find that. I think if you type in EA rain gauge finder, there's a map and you can zoom in and find the rain gauge. And if you click on that, it will show you the sort of the last 10 days data. Once you have that, the station ID, then you can basically enter a string into your search engine. It will download, I think it's the last 3 weeks of data, like actual data from the rain gauge. So I can share, I could tidy it up, because it's using the API strings. So once you've decoded the language, then all you need to change is the 5-number station ID, and that will, so rather than just having the daily totals that you get from the EA rain gauge finder on the little map, you can download, the 15-minute data from each rain station, and the same with their flow network.
Okay.
That's similar to what we do. But if you've got people with coding skills, you can obviously go one step further and automate that whole process. And so I know with us, there's just a data grab. I think it's once a week. It fires that API with, I don't know if it's all the stations or a selection of stations, and it just grabs any new data and appends it to the store. Because the problem with that EA API, it will only give you a certain chunk of data. I think it's up to 2,000 records, which, is obviously quite limiting. But if you can set up some kind of automatic iterative process, you can start building up your own database of the EA data.
Yeah. Well, it'd be good to maybe pick Stantec's brains on that, James, at some point. Okay, thanks, guys. We've only got sort of 5 minutes left, so I'm going to pick one more of the surgery questions. But if anyone's got any other questions that they want to ask, post them in the chat, and we can always pick it up afterwards. And I've hopefully Lucy sent an invite to the Slack workspace that we've set up around the Catchment Monitoring Cooperative that we are looking to build. So we want to really sort of carry on the discussions afterwards. So I do encourage you, if you've not used Slack before, just sort of follow the link and you should be able to be joined into the workspace, and you can start to ask questions of the community that's building on there. So one of the other questions was, how do we share data effectively? How do we, well, it says, how do we encourage Rivers Trust to share the data with partners? But I think that applies to all catchment partnerships and local groups collecting data. So Pete or Simon, who would like to pick up that one first?
Should I let Pete go first on this one?
Yeah.
Okay. Well, first of all, it's not really my subject, sharing data and databases. I'm all about making sure that the data is reliable and good quality in the first place before it goes on to databases. So I would say, please spend a lot more time on that side of it. It's no good having a database and shared data when the data is unreliable. Other than that, I can't really say much.
Thanks, Pete. I think it really underlines the importance of pairing up different skills, because I'm more about the sharing data and you obviously have the sort of understanding what it means. And I think between us, it really helps to sort of share our knowledge and make sure that what we are sharing is understandable and meaningful. Simon, what about you? Your thoughts on sharing data?
Yeah, so I would say, from my experience, when I first joined West Country Rivers Trust just over 5 years ago now, we weren't really sharing very much data with the EA locally. We had done, and then staff had changed, and then we weren't. So we have rebuilt that process via the strategic monitoring review catchment prototypes, really. And it came from actually meeting up in person in those days you could do that sort of thing, and coming to the table with putting all your cards on the table, I suppose, understanding what each partner was kind of, what their objectives were and what they were bringing to the table in terms of data. And then what Pete says about the quality of the data, I think, is really important. And particularly people knowing what the quality of their data is and that data consistency. So when we sat down with the EA and we had a load of our spot testing stuff, which was done with the in-field instruments, and it was, and we looked at it in parallel with their, you know, statutory monitoring, and we could both have a conversation about what the priorities were in the catchment and what evidence we had to back that up, knowing what the quality and the various limitations of each data set was. So I think that was really important. Then we've not let go of that data set really either. So we have not at no point said to them, here's a spreadsheet of our results, go and do what you want with it. We've always said, well, here is our interpretation of that data because we know the limitations of it. Show us your interpretation of your data, and then let's work on that together. So it's kind of, you know, it's not sharing the raw data, and that's not necessarily because we're secretive about it, but that without the understanding of the limitations and the conditions under which it was collected and the objectives of that monitoring program, it's not really safe to be interpreted on its own. And this is something you'd find with some of the EA data sets, is, you know, you control their open data, but without the kind of understanding of why that data was collected, you know, there's a risk in taking it as gospel in terms of interpreting it and taking actions based on it.
Yeah, thank you. And Pete, you said as much as well in your presentation about, you know, those sort of flags and data warnings need to be part of the data set so that we can really interpret it in the right way. I
mean, that's absolutely true, and it's so sad that so much data is taken and used by whether they're consultants or academics or modelers, and the end results are dreadful because the data wasn't of the appropriate sort to be used like that.
Okay, well, I think that just about wraps up the day, and I'd just like to thank Lucy and Simon and Pete for pulling together the content today. I think it's been a really useful couple of hours. Hopefully everyone has got a lot out of it, but we'd love to hear your feedback. You know, do sort of drop us an email, get in touch on the Slack channel and let us know what other sort of training and support and knowledge sharing you'd really like to be able to sort of make the most of your monitoring in your catchments. And please do sort of continue to engage. We've had some other sort of questions and responses that we'll share. We'll probably put those on the Slack workspace as well, I think, just to sort of give you a motivation to get on there, and obviously get in touch if you have any problems accessing that. And thanks very much, everyone. And yeah, hopefully we'll be running more of these events in future.